Hello, my name is Luke Fain, and this is my presentation on the National Parks of Washington. Figure 1 is a simple geologic map of the state of Washington. These three parks are connected because of their location in the same state, formation during the same orogeny, and the similar rock types found in the park, which will all be covered in this presentation. The three current national parks in Washington are Mount Rainier, which was established in 1899, Olympic National Park, which was established in 1938, and North Cascades National Park, which was established in 1968. Figure 2 shows the locations of the three parks. Next is some history of the area. According to the National Park Service, ancestors of modern tribes would come to Mount Rainier to hunt and gather resources, and people lived near the mountain around 15,000 to 10,000 years ago. Figure 3 is an image of the mountain. In Olympic National Park, people have been traced back to around 13,800 years ago because of a mastodon bone being found near the area with a spear point still embedded in it, as seen in Figure 4. The people there tended to hunt big game, and about 3,000 years ago, they shifted towards fishing and hunting sea mammals. Next is how the parks formed. For the past 34 to 42 million years, the Juan Fuca plate has been subducting under the North American plate, causing accretion. This is known as the Cascadia orogeny and is still occurring today. This is how the Cascades formed, and the volcanoes of the Cascades form above where the Juan Fuca plate subducts at about 50 miles underground, which is depicted in Figure 5. The Olympic Mountains are part of the Cascadia orogeny and were also formed by subduction, just a little later. According to the Washington State Department of Natural Resources, sandstone, shale, and basalt are the three main rocks that make up the Olympics. Most of these originated underwater because the Olympic Mountains began forming underwater from underwater volcanoes, which is seen in Figure 6. Almost all the basement rocks found in these national parks are in the North Cascades. The oldest rocks are Precambrian, and Figure 7 shows rock type, age, and general location of the rocks in the North Cascades. According to the North Cascades National Park Geologic Resources and Inventory Map, gneiss and amphibolite from the Precambrian are found in the park. Figure 8 is a photo of Custer gneiss, which is the oldest rock unit found in the area. There's also sedimentary, volcanic rock, greenstone, chert, and limestone from the Permian to Devonian period. We see schist, marble, and quartz diorite from the Triassic period. Marine sediments from the Jurassic period are found along with magnetite, diorite, and metaconglomerate from the Cretaceous period. After this, many other types of rocks found in the park date all the way up to the Holocene epoch, which is the present epoch. Staying in the Cascades, but moving most of our focus south, we're going to look at recent volcanism. There are 5 major volcanoes in Washington, with all of them being located in the Cascades. Figure 9 shows their names and locations. These are all active volcanoes, and the Washington State Military Department says the last volcanic eruption in the state was Mount St. Helens from 2004 to 2008. Focusing our attention on Mount Rainier, which is shown in Figure 10, according to the National Park Service, a previous volcano was once located where Mount Rainier is around 1 to 2 million years ago. Mount Rainier began forming around 500,000 years ago and has been built up by many eruptions. Mount Rainier is part of the South Cascades, so some of the surrounding rocks will be similar to the North Cascades. As for Mount Rainier itself, according to the Mount Rainier National Park Geologic Resources Inventory Map, some of the oldest datable rocks consist of rhyolite and basaltic andesite flows from the Eocene epoch. There's also diabase, basalt, quartz diorite, granodiorite, and quartz monzonite from the Oligocene to the Miocene epoch. Mount Rainier plug and dikes from the Pleistocene epoch, and most recently andesite flows, mud flows, and interlaid breccia from the Holocene and Pleistocene epoch. Next is the Olympic Mountains. Figure 11 is a photo of Mount Olympus, the tallest mountain in the Olympic mountain range. Figure 12 showcases some of the types of rocks in the park. According to the National Park Geologic Resources Inventory Map, the oldest rocks found in the park are gabbro and diorite from the Jurassic period, along with volcanic and sedimentary rocks from the Cretaceous period. Then we see sandstone from the Paleocene epoch. From the Eocene epoch, we find breccia, gabbro, and basalt. Then there are a bunch more rocks leading up to glacial drift from the Pleistocene epoch and alluvium and beach deposits from the Holocene epoch. Next are natural disasters in the area. Volcanism will be an issue here. One example of volcanism in the area is the eruption of Mount St. Helens. The U.S. Forest Service states that on May 18, 1980, Mount St. Helens erupted after a 5.1 magnitude earthquake. Figure 13 shows the eruption occurring, with Figure 14 showing the volcano's appearance after the eruption. Earthquakes are a potential danger. They can prompt a volcano to erupt and also cause damage in other ways. It is also worth mentioning that tsunamis and flooding in certain areas could be potential dangers. Next is paleontology and paleoclimate. For paleontology, there's the previously mentioned Manus mastodon. Also in 2012, a paleontologist from Burke Museum discovered the first dinosaur fossil ever found in Washington state. They reported it being around 80 million years old and that it looked to be a partial left thigh bone of a theropod dinosaur. Figures 15 and 16 show the bone still in the ground and then a comparison showing how the partial bone would fit in the full size. For paleoclimate, I found a research article titled Paleoclimate Changes in the Pacific Northwest Over the Past 36,000 Years from Clumped Isotope Measurements and Model Analysis. The study takes place in Washington, and they found that since the last glacial maximum, the regional temperature has increased 16.4 plus or minus 2.6 degrees Celsius. They state that this is 2.5 to 3 times the global average, and that this anomaly is likely due to where they conducted the study and its close proximity to the glacial margin. Figure 17 shows Washington's annual precipitation. You can see there's a wide range, with some areas getting upwards of 200 inches of rain a year, and other areas getting 5 to 10 inches. The climate has greatly changed in the area over millions of years, and the current climate is quite diverse. This leads us to glaciers and climate change. Washington is the second most glaciated state. Figure 18 shows the alpine glaciers in the parks and South Cascades. According to the NPS, there are 28 named glaciers in Mount Rainier, and there are over 300 glaciers in the North Cascades. Sadly, climate change is causing glaciers to melt. The NPS states that in 1982, there were 266 glaciers in Olympic National Park. As of 2009, that number had dropped to 184. I found an article that was published in December 2024 for more recent information. The article, titled "The Status of Glaciers in the Western United States Based on Sentinel-2A Images," looks at and compares satellite images to determine glacier conditions. The authors write about how glaciers are melting largely due to human activity, since humans have played a big role in climate change. The research shows that during their study, a little over half of the total glaciers lost in the western U.S. were in Washington state. They also give the statistic that the glacial area in the North Cascades has decreased by 30%. Looking at figures 19, 20, and 21, we can see a drastic change in some of the glaciers found in Olympic National Park. Sadly, the glaciers in Washington are disappearing, and humans have played a big role in that. In conclusion, the national parks of Washington state are beautiful, diverse, and have a rich history. Figures 22, 23, and 24 are some pictures of 3 parks to illustrate that. That is the end of my presentation, and here are my resources. Thank you for watching.